Welcome to the Land Tamer stream. Good to be back. I was out yesterday. I had to travel for work and didn't get home until kind of late. So I'm back today, and we're going to do a couple lab. I'm also on call, so I missed. I'm having to start a little late, and hopefully there won't be another call. But I got 2 labs lined up if time works out. If I get through these, they are with OSPF. And this time we're dealing with some more subtle areas. The first one is multi-exit ABRs. In other words, I have an area with multiple ABRs and looking into area 0 and want to control some of the traffic going in there. Actually, before I get started on that, let me just review some of the links. I'm trying to incorporate this feature into the stream where we all have a fire hose of information coming at us, especially network engineers. There's constantly things that we're trying to stay up to date on. Whatever, choose whatever your medium is, whether it be Twitter, Facebook, YouTube, blogs, RSS feeds, whatever the case may be. I know, probably everybody watching does that. I figured it might be a good idea. Yeah. Hey, Divisible, what's going on, man, with the Nexus upgrade? I know you've been working on those. Hope those are going well. 5Ks, right? I think you said. Yeah. I want to go over some of the links of the day, so I'm going to try to incorporate these. I had some really good ones. This is probably like 3 days of links, actually, and I want to share those. Let's see. I'm going to leave them in the YouTube description, but a description of the video, so you'll be able to see them there. Yeah, how to shut down. Man, I even know how to do that. I'll bet you know how to do that too. Come on, shut down the machines, guys, so we can upgrade the switches. Come on. You got one job, right? Shut the servers down. Hang in there, buddy. Hopefully you won't be too late. Yeah, so these are some of the links. I've actually got 4. Wow, I didn't even realize I had 4. But they're in the last 3 days, I've seen some really good videos, and these are only 4 that I thought I'd share with anybody watching this. One was called Knowledge Mortgage by Russ White. We all know who Russ White is. He's a router god, and he's one of the 10 CCI architects, CCAR, I think they're called. He's one of like 10 people. He had a really good article about learning and some real good principles there. I'd recommend watch highly. I think that's off of his site. It's just a video embedded in his site. Then there was another one posted, I think, a router guy's Feynman learning technique. Really good, about learning in general and how explaining things makes you a better teacher and makes you a better learner, better student too. And I will say that having to vocalize when I'm learning on stream, I can certainly agree. That helps me to really understand if I can explain it. Just kind of the function there. Really good video. And then Casey Neistat, he talks a little bit about vlogging and how he got started, kind of his story. This is kind of a longer video, but man, this guy has an awesome channel. He's a superstar on YouTube anyway. So I'm really into YouTube, but he's got some fun videos. My wife and I were watching them during our lunch break. Just mesmerized. And then, of course, if you're subscribed to Network Collective, you follow these guys on Twitter. They had a new video this week. Actually, 2. They came out with another one today. This one is about OSPF and had Russ White and some other ones. If you haven't watched episode 9 yet, highly recommend it, especially for me because I'm going over OSPF. I was like, wow, some of these designs they talked about were really intense. But anyway, those are some great links I'd highly recommend. And those will be in the video notes, so you can reference those. But we'll go on to this lab here. Multi-exit ABR. So this is the scenario. You have we got sort of a slightly changed topology. So we've got, we're going to have to disable this link to area 6 just to make it simpler. And we're going to have area 1 and area 0 is what we're going to be working out of. And what I think the lab calls for is to create a loopback on router 6 and redistribute it. So we'll have an external route. So we will have, basically this will be in router 1, in router area 1, we'll have some routes going out into area 0 that are external from this router 6 loopback. But what we want to do is we want to control, the requirements are that once we distribute this loopback, that we want to configure area 1 as a not so stubby area. And we want to control how routing is done. So from router 6, routes coming from router 6, basically your external routes, in this not so stubby area, we want them going via R1. Okay, so that's going to be our inter-area routing from router 6. Basically, router 6 going into router 0, right? Go in this direction. We want inter-area routes to go this way. And then we want routes that are external to OSPF. It says from router 6. I think what that means, let me look back at the terminology there. All traffic from router 6. Okay, it's supposed to take an hour from time they shut down to the time the network is back up. Oh gosh. So you basically have, yeah man, let's WebEx, give me a CLI, we'll do it. Gosh, so you basically have like 20 minutes left. I wonder if you're gonna have time to do those upgrades, man. I don't know how many switches you have to do, but we're gonna pray to the land gods here. We're gonna conjure up all that we can, and we'll be rooting for you, man. Hopefully, they should be getting those servers shut down though. Like 40 minutes. Come on. How long does it take? What are they running? Oh, I wonder if they have like a bunch of services or applications that they have to shut down. They don't know which ones to do first. I don't know. That sounds sketchy. Wish you luck, man. Fingers crossed. You have a very small change window. But yeah, what we're doing here is, again, we're going to take, so let me make sure I read this right. Traffic from router 6 destined to inter-area OSPF prefixes is routed through R1. Boom. Okay, yeah, so this is a not so stubby area. So what we're going to say is we want the inter-area routes going this way, and routes from here to area 0, external going this way. Oh, you just want to take an hour. Yeah. You didn't want to be up till midnight, right? Wanted to, yeah, hopefully get it done quick. I hear you, man. I hear you. Isn't that how it often works out? You know, you set aside a certain amount of time, and it always seems to take longer. I had people tell me at some point, whatever Quentin tells you how long it's going to take, multiply it by 2. Oh man, yeah, if they can't get in the servers. You know, in VMware, it does a pretty good job of shutting down gracefully. Like when you right click on the virtual machine and tell it shut down, it does pretty good about talking to the operating system and shutting things down. Like some people though, they want to remote desktop or console into the server, log in, do start, shut down. But my experience anyway is you know, in VMware you've got the shutdown and then you got the power off. Yeah, granted. I know, right? Tell them to pull up the stream, man. Tell them to go to my channel and subscribe. And I'll help them with VMware. Actually, I did have my VCP version. It's old though. Like version 4. Was it 4.5 or 4? Yeah, I actually got my VCP because I had to. So yeah, I can kick around VMware, but man, that is annoying. I know how that is. Yeah, they can. They can actually right-click, power off. Boom. It's basically the same thing, right? Looks like you might be having a long night, my friend. Unfortunately. Yeah, so what we're going to do here, guys, is again, we're going to take traffic from R6 destined to external OSPF prefixes is routed through router 4. Now, I'm not sure how that's going to happen because in this lab, are we advertising? Oh, we are. Okay, I got this backwards. On router 5, we're redistributing. So this is going to be our external route. And what we're going to want to do is say when router 6 goes there, he goes to router 4. And before I'd even watch the video, INE, by the way, has excellent videos on this subject and the next one, which is the LSA 7 to 5 conversion. Great videos. But I'd already actually figured out how to do this. Yeah, I hear you, man. Yeah, server folks. And you know, they always blame the network people too, right? Network always gets blamed, but I always blame the server guys or the storage guys. But yeah, they so I need great videos on this, especially this one. When I first read the requirements for this, I had no idea how to do it, but the INE video cleared that up for me. So in area 1, we're going to configure it at first. Let's go ahead and disable this link. I'm going to pull up my terminals. I wanted everybody to see my new wallpaper background, my new line. I try to switch my lines out once in a while because I get bored. There's so many great line shots on the interwebs. Anyway, we're going to shut down this link just to make the topology a little simpler. And then on router 5, which is kind of our main router in this whole scheme of things in area 0, right? He's kind of the center hub for everything. He's going to be redistributing his loopback. This loopback 100. And just to make it clean, I am going to do a route map. RMAP 1 permit. I know capitalization doesn't matter there, but match interface L100. Router OSPF 1, redistribute. Connected, subnets, route map. And we'll use default metric. Cool, so that is now redistributed. So before we make these changes, we should see this on router 5 or 6 as the OSPF database as an external route. It hasn't got there yet. Let's make sure it's redistributed correctly. Show. Actually, let's look inside the area. So let's look at router 1. Show IP route. Should see an OE2. Did I not do that right? Show IP interface brief. There's loopback 100, 160.1.5.5. Show run in router OSPF. Redistribute connected subnets route map RMAP. show, oh, it's RMAP 1, duh. Let's actually pull this back up. And I learned a trick from Brian McGann. He'll do a show run copy, like all this. Well, this is kind of a short configuration. He'll put it back in if he wants to do a no, and then just know that. But he'll do that with a long configuration, which is cool. Now RMAP 1, now we should be distributed. So let's check on router 4, or actually router 6. And now we have this external route. Actually, it's 160. Yeah, and we have reachability. So what we want to do is control that path. We want to configure area 1 as an NSSA. So we need to do that on all the routers, which is router 6, 4, and 1. So we're going to say router OSPF 1, area 1, NSSA. And we're going to do some changes here. I'm not going to change them yet. We're going to change this NSSA command to meet our requirements, but I want to go ahead and at least get NSSA configured so we can just look at the OSPF database before we change it. Area 1 NSSA, and then we're going to do the same on router 6. We did 6, 1. Yeah, router 1. So now this should be all NSSA in area 1. And what we should see on router 6 is show IP OSPF database. So we have router in area 1, we have router, I'll say 1s, 2s, 3s. Okay. Now notice when we do NSSA, just an NSSA does not generate a default route by default. So essentially, we filter out all our, well, no, there's a type 5s. Type 5 AS external link states. Okay. So let's see here. That should be filtering this. Not so stubby area. Maybe that's, maybe it takes a minute. External. LS age 124. It doesn't look like the routing bit is set though. Ping 16. Is it in the routing table? No, it's not. Yeah, okay, so it just hasn't aged out, but that will go away. We notice the routing bit is not set, so that's what we want. For now, we've got the NSSA configured. Now what we want to do is change the NSSA configuration so that inter-area routes will go via router 1. Now the way we do that, because right now we're still getting all the inter-area routes because we did not use a no summary option. So I have a ton. Show IP OSPF database summary. You know, in area 1, well, we saw them in the routing table, right? Actually, if we just do IP OSPF database, we have lots of summaries coming from both router 4 and router 1. Now, if we want to say we want these inter-area routes to go via router 1, not via router 4, what do? We just make the ABR router 4. We change the type, right? We change it to summary only. Make it a not so NSSA total stubby area. And I've seen it written that way, so I know you can say it that way. But that's how we do it here. So if we go router OSPF 1, we say area 1 NSSA summary. Say no summary. And remember, we can do that on each ABR. The no summary option. We can select which ABR we want to do that on. So now if I go to router 6, these will age out. Okay, look, they already did. So what happens? We get a default route. That's what the no summary option does. So now we still have routes. We can still get to all those through router 4. And that's the other requirement here. If we lose a connection to area 1, because we have a default route. However, we've met this requirement because the longer prefix match is going to make it go through router 1. Right? So we can do that, for example, trace route 150.1.1.1. And it goes through router 1. Boom. All right. Let's do router 8s. Yeah, it goes to router 1, then to the tunnel, router 5, then router 8. So we met this requirement. That works great. All right. Okay, so right now we're filtering external routes, and as an NSSA, it does not by default create advertise a default route into the area 1. But we just change it so that router 4 does now, right? We saw that it creates summary 0.0.0.0. See, now we're getting this from router 4 because we turned on no summary, which is great. So now we've met this requirement too, because we don't have a route to 160.1.5.5. However, we have a default route. An easy button. Yeah, man. I'm going to send you... I was trying to think if I have a really cool mouse thing that I could send you. I'm going to send you this flower mouse pointer, man. That's the same thing as an easy button. There you go. I just sent it over the interwebs, man. So, flower power. I actually had a boss who had an easy button. How many bosses have you had? I know I've had one, maybe two. I might have had two. I actually had an easy button on their desk. And I would hit it all the time and nothing would happen. I was like, man, this easy button does not work. Need to get one that works. I think CDW or someone was like handing them out because I saw a bunch of people that had them. But yeah, so we don't have that route, right? But we have a default route. So I should be able to reach 60.1.5.5, and I do. And we'll see that trace route 160.1.5.5, and it's going to go through router 4. Great. This is all fine and good. We've met these requirements. However, what's going to happen if we lose a connection on router 4? So let's say this link goes down right here, GI0146. Actually, no, let's say this link goes down on router 4, GI0145. What's going to happen? Well, we're going to have a problem because we'll still be able to get to our inter-area routes, our LSA3s. We still have all these coming through router 1, but we don't have a default route through router 1. And we're blocking LSA type 5s. So we'll have no way to get to that loopback we created, right? To that redistribution point here. We'll have no way to get to it. So what we're going to have to do in order for that to work is we're going to have to actually tell this router 1 to send a default route. But we still want to meet our requirements, right? We still want to take this path to their external routes. We don't want them to start going this way. So we're just going to originate a default route here with a higher metric. And we can do that on the NSSA command on router 1. Area 1 NSSA default information originate, and then we give it a metric. We'll give it like 500. Boom, that should give us what we need. So now on router 6, show IP OSPF database summary. I should have 2 of these. I still just have one from router 4. Didn't originate a default route. I'm going too fast. I just have to wait. That's my problem. So let's see what happens. Let me see on router 4. Router 1, show IP OSPF database. See if he has it yet. Oh, I need to see area 1, right? Still not seeing a default. Oh, I know what I'm missing. So the rules of OSPF default route origination. OSPF, in order to originate a default route, it has to either have learned a default route from another routing protocol and have it injected into OSPF. Actually, it just has to have a default route from another protocol, period. And then you can tell it to originate, but again, it will not do it if it does not know about a default route. In this case, as an NSSA. However, there is an option to force it. Default information originate, metric 500. What is that command? Default information originate. I think there's another command. Let's look on router 6. It's still only getting it from router. Okay, so it's not distributing. Why is it not distributing? Let's check our. Yeah, I saw I think it was a configuration guide on this. Let's pull up the configuration guide. IP routing OSPF. No, it wasn't here. Actually, where did I see that? Okay, it might have been under the technology document. IP routing. Technology white paper. OSPF design guide. Default. That's a lot to look through. Let me go back to the top. I don't think that's it. Not how to communicate. Okay. Default information. Okay, there are two ways to generate a default. First, to advertise inside the domain, only if the ASBR itself already has a default route. The second is to advertise it regardless of whether ASBR has a default route. That's what we want to do. Latter can be set by adding the word always. You should be careful when using the always. If your router advertises default inside the domain, routing will be broken. The metric and metric type cost are assigned the default route. Yeah, default information originate metric. Okay. I think that's the answer here. That's what I'm going to go with because that's all I know at this point. Router OSPF 1 default information originate always metric 500. Okay. Actually, I need to do this on router 1. Sorry. Or, yeah, router 1. Okay, so now show IP OSPF database. In area 1. Yeah, I don't see it there yet. Okay. Now we have it as a type 7. Okay, maybe I was looking in the wrong place. Type 7 area 1. Oh, see, now I have a type 5. I'm not sure that's the way we're supposed to do it. Yeah, I don't think that's it. So I'm going to have to look at the lab key here. Okay, router 1, area 1 NSSA, default information originate. That's what I have. Okay, I was making it too complicated. Let me take that command out. Show run in router OSPF. Yeah, it could be that I had it right, but because I did not see an entry for it in the database, but it could be that it does not add that until it needs to. Let's see. Yeah, NSA 1 default. I don't even need that, it says. Yeah. I don't even need a metric. Oh, I better know why. I'll bet I know why. Show IP OSPF database. Let's do it on router 6. Summary 0.0.0.0. Yeah, I'm still only getting default route from router 4. I would think I would see one from router 1 as well, but I don't. Okay, so we will okay, that's a right. That's a there it is. Gotcha. Okay. That makes sense. So, here's what happens. These are different types of default routes, right? Router 4, when we say area NSSA 1 no summary, he is taking all LSA type 5s and he is generating an LSA type 3 default route. Router 1, when we say default information originate, area NSSA 1 default information originate, he is now generating a default route, but that is in LSA type 7. And what happens with LSA type 7s? They will get advertised, or they will get converted from type 7 to type 5, but only one router, ASBR, is elected to do that conversion, right? And it goes to the one with the higher router ID. So router 4 is actually going to generate that default route and send it into area 0, or it should. Let's look at router 5 and see if he has the default route now. He did not before. Show IP route 0.0.0.0. Okay, does not. Oh, could it be that the no translate bit is set on that default route? It is. No type 7 to 5 translation. So that is inside area 1 only. Clever. Okay, I like that. That must be by default. Let me see. If I go to router 1, can I say router OSPF 1 area 1 NSSA default information originate? Limit default advertisement to this NSSA area. That must be on default, by default. Because that's basically the behavior. Because it sure enough sets the no translate bit, the P bit. It marks that as, look at that again. I was on router 6. Yeah. So what he does is the P bit is set, no type 7 to 5 translation. So this is just enter area. And what happens is, apparently in OSPF area 1, I'm always going to use a summary 3, LSA 3 default route over a summary 7, because what is my route now to 160.1.5.5? I still wanted to go through router 4, and it does. Yep. Good deal. Okay. All right, I think we have now met the requirements. The only way to really test this is to drop an interface. Let's go over here to router 4. Interface GI01. Well, let's see. He has, all right, he has 2 interfaces, doesn't he? So just for good measure, let's take down the, let's take down both interfaces. 0100 and 0145. Shut. Actually, we can just take down the tunnel interface. Okay. So that should drastically change the OSPF database. And we should still, from router 6, even though we're in a not so stubby area, we should still have our default route now from router 1, right? Let's see, show IP OSPF database, summary 0.0.0.0. We still have it, but the routing bit is not set, so it's going to age out. If I do show IP route 0.0.0.0, yeah. This is router 4 still. Trace route 60.1.5.5. Interesting. I think that's just an age out issue. Show IP OSPF database external. Yeah, because we still have an adjacency with router 4. Clear IP OSPF process. Let's do that. Oh, you know what? Router 4 could still be learning it through that. We should just shut down the whole interface, not just the tunnel. 0, 1, 100. Yeah, I didn't have any adjacencies there. Show IP route 0.0.0.0. Not in the table. Okay, see. Okay, it's still converging. So, okay, there we go. Interesting. We still have an adjacency with router 4. Let's shut it down the other way. Show IP interface brief. Actually, interface GI 0, 1, 100. No shut. Interface tunnel 0. No shut. Interface GI 0, 1, 146. Shut. Okay. So now, clear IP OSPF process. And on router 1, clear IP OSPF process. Yes. Show IP OSPF P route on the routing table. Oh, it's not going to advertise it to itself, right? Yeah. There we go. So 160.1.5.5. And that works, the router 1. Okay, we met our requirements. Let's shut down the other interface too, just for being, just to be thorough. Let's bring that interface back up. And on router 1, we're going to shut down his interface. Okay, yeah. So now router 6 should still get, yeah, 160.1.5.5. You can still get there. And let's try another loopback, 150.1.8.8. Oh, that's not going to work because oh, it's probably still converging. Show IP route. Okay, now it has that route. There we go. Just need to converge. Cool, meta requirements. Good stuff. All right, guys, so that takes care of that lab. Let me just double check the lab key, and yeah, that looks good. Everything is fine and dandy. And what time is it? Yeah, well, we got time for one more, I think. Okay, type 7 to 5 conversion election. I'm going to leave some of this configuration in place. Let me just take out, let me just bring these interfaces back up. And let me take out the default routing configuration. Router OSPF 1, area 1 NSSA. Same here. Router OSPF 1, area 1 NSSA. Okay. I think that puts us back to where we were. We'll leave that enabled. Extra loopback doesn't hurt. One extra loopback don't hurt anybody. All right. So what I learned about today is, first of all, when we flood LSA 7s into an area, there is a conversion that takes place, right? In most cases, by the default configuration, and not all ABRs are going to do that. Are going to then convert and flood LSA 5s into area 0, into the backbone. There's an election that takes place, right? It's going to be, by default, it's going to be an OSPF, the router with the highest router ID. So in the case, for example, of area 1, if we configure as an NSSA and we generate type 7s, LSA type 7s, and those get flooded into area 0, router 4 has the higher router ID, so he will be the router to send the type 5s, the converted type 5s, into area 0. And what will happen is he will be the advertising router, but as we know, with an LSA type 5 that has been converted, there's a forwarding address that is used. And that's really what is used to calculate. It's not through which ABR, that doesn't really matter. It's going to run SPF on the forwarding address. And that's how it will calculate how to get back. So just because router 4 converts type 7s and floods the type 5s here, doesn't mean it's going to come back through router 4, right? It's going to use a normal SPF process to make that determination. Well, what if we want to control that? What if we want to control which router does the conversion? And that's what this lab is for. So what we're going to do is we're going to continue the configuration here as an NSSA, which we already have configured. And we want to create a loopback on router 6 because router 6 is going to become the ASBR because it's going to do redistribution into OSPF. So let's say interface loopback 100, IP address 160.1.6.6, and route map rmap1, remit 10, router map. I do that sometimes. Yeah, it's a router map. Remit 10 and match interface L100, router OSPF1, redistribute connected subnets, route map rmap1. What else? Yeah, that's all we need. So now on router 5, for example, we should have a route. And in this case, it's a not so stubby area. So that's going to allow the 7 to 5 conversion. And we should have external. And we have 160.155. That's the loopback that we created. And we have this new one. So here it is, 160.1.6.6. And the advertising router in this case is router 4. Now we're going to change that. We want to change that so that this is router 1 and that only router 1 distributes these, right? Now notice here, this is a forwarding address, 150.1.6.6. So this is what we really use to determine which path we're going to take to get there, right? So the way we would recurse this is we would say, okay, do we have, first of all, do we have an LSA type 1 or 150.1.6.6? Database, router, 150.1.6.6. We do not. So then we need to see, do we have a type 3? Do we have a summary address for this? Show IP. And again, the difference here in a lot of calculations in SPF, or in OSPF, this, in the case where it is a link ID for a router, that is just the number that matters. But in the case of a forward address, this is an actual link address that we're going to use to determine the calculation for it, not just a router ID. This could be, the router ID could be 7.7.7.7, but it actually needs to have reachability to the loop. In this case, it usually selects the loopback as a forwarding address, but this is an actual IP. So I'm going to see if I have a summary. 150.1.6.6, OPS database. Summary. And I do. So I have reachability to this network. So it will use that to calculate the path. And in this case, I have in area 0, I have through router 1, the metric of 2, router 4 with a metric of 2, and through router 5 with a metric of 1002. So I probably have, yeah, I have 2 paths that I can use to reach that. So then it's up to Ceph, right, to determine, because my reachability, my metric to these ABRs is 1000 plus a metric of 2. So there we go. That's how we determine reachability to this external route. So I can do that by show IP. Well, I can do trace route 160.1.6.6. There we go. All right, so what we want to change here, though, our requirement is that we want only router 1 to advertise this into area 0. So we want the conversion to take place only on router 1. And the way to do that is, from what I learned today, we want to do, what is this command? Translate, right. Translate type 7. Okay, so always, there's a couple of things we need to do here. So first of all, the command is translate type 7. So we're saying on router 1 that we're going to do a translate type 7 and always translate LSAs on this ABR. So what we're doing is we're saying router 1 will always win this election. We're always going to use him to do the 75 conversion. Not only that, but we're going to use this as well. Because remember, even though, well, hold on, let me see what the requirements are, because whether we need to use suppress FA, only router 1 advertises this loop back into area 0. Only router 1 advertises. It does not say that we want to always use router 1 to reach this loop back. That may be, I'll bet you that's a future lab, because that's what this would do, suppress forwarding address. And the suppress forwarding address would take out external, let me, 160.1.6.6. It would set this to 0, right? And it would change the advertising router to 150.1.6.6. So that we would, or 150, 1.1.1.1. Because right now we're sending through router 4. This is about to change though. Let's go ahead and make that change. Let's just set that always. So now we go to router 5. Now we have 2 entries, right? Through router 4 and through router 1. But notice the age. This is going to age out. So now it's going to be advertised. The advertising router is always going to be router 1. Okay, if we wanted to make this take the path of router 1 every time, we would use that other suppress forwarding address option, and this would be 000, and then we would have to route through router 1, but it doesn't say that. So let me see if I got that right here on my key. Router as an NSA. Change election. Okay. The key has it doing it another way, which is fine. And I can see why that would be the case. So if we do this, here's the problem with the configuration we did on router 1. And there's another way to do this, and that's what I just saw from the lab. When I saw it, I was like, oh, yeah, of course. So if I set this to always, but I lose a link, so for example, I lose the link on router 6. Let's say this link goes down. Well, guess what? I am still going to, router 1 will still be in area 1. And he's still going to have a copy of the OSPF database. That would still work though, even if he advertises it this way. Again, it's just getting the advertisement out of the area. I guess my solution would still work. What the lab is saying is that we could change this router ID. I don't like doing that though, to be honest. You know, here I am saying that my way of doing the lab is superior to the way that the INE is saying do the lab. We're getting big for our britches these days, aren't we? So here's what they're saying. Take this out. Actually, I should just say Area 1 NSSA so we don't drop adjacencies, right? To change the router ID, so if I go router, I'm already in configuration mode, but I can say router ID, and I can make it higher than router 4, right? And by doing that, it's going to win the election from here on out. That's another way to do it. I tell you though, if I did this on my job, well, you know, there'd be a problem, right? Anytime you see someone not use a consistent router ID, usually there's a standard, right? Usually there's a standard at any job. You have a standard for which IP space. You know, you depending on where you work and how large it is, you might have, you know, IP Nazis, right? Who you are required to use for any loopback address. It has to fall into this standard configuration, right? This standard numbering scheme. For your point-to-point links between routers, right? Your point-to-point interfaces have to use this routing scheme. Any place worth working at is going to do that. But what the lab is saying here is that I can come in here and change, and granted, true, they're trying to prepare us for the real CCIE lab, where they're going to ask us to do crazy stuff we would never do in production. But anyway, they're saying that one way to do this is router ID, make it a higher number. So we can make it 254.254.254. It's saying, hey, okay, yeah, you gotta reload. Yeah, just reload the router. Geez, we're not gonna go that extreme. We're just gonna clear the processes. So by doing this, yes, that will have the same effect, right? Now if I go over to router 5 and I look at the same LSA type 5, again, well, let's wait for convergence, right? We're in the lab, we don't have rapid convergence timers. What I'm going to expect to see, though, is that this will now come through router 1 because he has the higher router ID. So like if I go show IP OSPF database router, actually show the OSPF database and just, this is so much easier, right? Oh, that did area 0, didn't it? That's why. That looks ugly, doesn't it? Man, that looks ugly. Okay, let's change it back. No, it did it for router area 1 too. That's right. That's okay. Age 40, link count. Good deal. Okay, there we see we just had another adjacency. Boom. We're still converging. Just had to be patient here. Okay, so now we see it coming through. Look at the LS age. See, this is already set to max age, even though we have 2 LSA entries here. This one through router 4 is going to go away, and now the election means that router 254, 254, 254, 254 is always going to do this conversion election while his interfaces is up and the routing process is up. And notice here again, we have the forward address, which is the main key piece of this converted LSA type 5. So good deal. And I'm going to look through the detail. There's a long explanation on this particular lab. But that is the configuration that was used. And that'll work, right? But kind of drastic. You had to clear the IP OSPF process, right? Another reason I think. I'm just saying. There must be some reason why the method I use would not meet these requirements, but I'll check on that. Anyway, I think that's going to be kind of wrap up the labs for tonight. Guys, thanks for tuning in. The Bizzle Man, I hope your VMs are shut down and your upgrades are going good, finally. And you don't have to stay up too late. May all your switch upgrades be successful, and may there be no outages tomorrow. May all your codes work great. Thanks for tuning in, guys. Be sure to check out, once the video is processed and saved to the channel, you'll be able to see all those 4 links if you want to check those out. They're pretty good stuff. Thanks for tuning in. And I may not be labbing tomorrow. Wife's birthday tomorrow. Going on a date. So if not, I'll be back on Friday. We'll see you guys then. Take care.